Okay friends, today in this particular lecture we are going to study about or how to design the layout of an CMOS inverter using a tool called Microwind. So now here you can see that there's a palette. In this palette you can find different kinds of layers. The first one you can see there's a N layer, P layer, and all this whatever you find over here are the contacts. These are the contacts. Then all these are nothing else but different kinds of metal layers. So first, in order to draw the uh, PMOS, we need the P diffusion. So we are clicking on the P diffusion first and drag over here. 4 is the length, and then this is my 4 is the width, and this is my length. The similar fashion, come down, exactly check exactly this below we are supposed to draw the NMOS. So for drawing the NMOS I'll be selecting the N diffusion. So now I have completed my N diffusion. So now if I go to the top, you can find over here, you can see that on the P diffusion we are supposed to draw the what is that uh, source and drain. So for that one we need a metal layer. Take this metal one and the source of the PMOS in the upward direction. So I'm drawing it in the upward direction, and this is one kind of layer and this P diffusion is another kind of layer. So try to put the similar kind of layers. So you can see the names of this layers over here. It's a P diffusion and metal layer, this one. So drag it and place it over here so that the a fixture will be made between this metal layer and the P diffusion. In the similar fashion, take the metal layer and drop it in the downward direction. Why? Because the drain, both the drains are to be connected. So I have drawn this drain part, the downward direction, P diffusion and metal layer, the same kind of contact. You make a contact between this one. Now we have completed this one. Now between the source and drain we know that there should be a what to say, gate terminal. So the gate terminal will be done or drawn with the help of polysilicon. This is a polysilicon. uh, I'm drawing the gate terminal 2 cross L. The width I have taken here is 2 lambda, and for the source and drain it is 4 lambda. 4 cross length is an indefinite. You can draw it the length as per your requirement in this particular software, and this is the width of the source and drain is we have taken it as 4 lambda. 1 2 3 3 lambda we have taken over here, and for this one we have taken 2 lambda. So now coming, we have completed a source, drain, and gate terminal. Now upon the CMOS, we are trying to draw it with the help of a N-well fabrication process. So upon the PMOS, we make a connection of N-well. It is of this is our N-well we have drawn. And next, coming back to this one here, the first we'll try to draw the source terminal. So I'm drawing the source terminal over here. The reason is that why? Because I can in this NMOS, the source and drain are interchangeable. You can either draw, you can take this part as a source or this part as a drain, whatever it may be, as per your requirement. Why? Because here I need to make the short, both the drains are to be connected. So I'm taking the NMOS drain over here. So I'll draw this drain in the upward direction, because we know that the output of this inverter occurs from the shorter drain terminals, and directly I'm connecting both this one. Why? Because I need to obtain an output over here, and we have completed now source and drain. The same fashion, make a contact between this N diffusion and the source and also drain. So this is the contact, N diffusion and metal one. So place it over here, click on this contact and place it here, drag it and place it. The similar fashion, click on this contact and drag it and place it over here. Now we have made a connection between source and drain of a NMOS. Now this particular gate terminal can be drawn with the help of polysilicon. Exactly below this one, I'm drawing the gate terminal. So why? Because the input has been given to the shorted gate terminal, so I'm making all the connection of this input. So now we have completed the source, PMOS source and drain and gate, and also NMOS source and drain gate. If you press this one, all option, you can find the complete uh, layout of this particular diagram. Now we are supposed to place the supplies. For the power supply, this is the option. You can see the VDD supply. You can see the name will be displayed VDD supply. Take this one, click it and place it over here. The same fashion, ground to the source of the NMOS, place it over here. Now make a contact. This contact should be used for the VDD contact, this one and also this one. We have made a contact between VDD and also ground of the both the PMOS and the NMOS. Now we are trying to give the inputs to this particular CMOS inverter. First, I'll use a metal 1, metal 2, metal 1 for giving the input. That input will be triggered from the gate terminal. So I have drawn the input, and also here you can see when the two same kind of metal layers are being drawn one upon the another, you can see the merging of that particular layer takes place. So but here it is the same kind of metal layers. This drain terminal one was the same metal layer, and this path which we have created for the output terminal is also same type. So that's why the merging has taken place. If it is different, you can find in this fashion. So now these are two different kinds of layers. So now we are supposed to make a contact between this metal one and also polysilicon. You can find that one over here. This is a metal and poly. Take this one and place it over here and give the input terminals. So inputs can be driven by using this one option, text layout. You can give the name of that input. Input is, we are giving the pulse wave. So this is a pulse wave. The name is V in. V in is our input, and assign it. You can find that one. And also you should make a contact. So use a contact, this contact upon this input and also the layer. And again in the same fashion, use this one contact, and here we need the output. So click it there. It's the out button, and here don't select anything. Make it as just give it as out, visible in simulation, assign, and make a contact. You can see this one now. Now we have completed the CMOS inverter design layout of this particular CMOS inverter design. Save this one. Once after saving, you can save it as a you can save it as a inverter 1. I'm just saving it as, or else it will be saved with an example .msk file given the name as inverter 1. And now after saving, use this button which is called as run simulation. Once if you run the simulation, you can see this one. You can see that the N well is floating. What does this mean? Here we have for the N well we are supposed to give the power supply. You are supposed to give the power supply. So again I'll close this one, and I'll try to give the power supply for this one. You can see the power supply palette. In the palette I'm taking the power supply. I've made a power supply. Again save it and then run it. So it's only the pulse one. So that's why we have got this output over here. Then again you can see this is not in simulation, visible in simulation. Save it and you can see it. It is invisible in simulation. Instead of that one, I'll take it as a clock pulse, so we can see the complete all the cycles of this different kinds of pulses. You can see this one. So this is our input which we have given over here. These are V input. Run it again, reset. You can see, or you can remove this grid so that You can click find it clearly what is happening over here. uh, See now, whenever you have given input 1, whenever the input is high, your output is going to be low, and if the input is low, your output is going to be high. So these are different sets of input clock pulses which you have given for that one. For whatever the input you have given, depending upon the input, if it is on high, you are going to get the low as an output. That is nothing else but the working condition of an CMOS inverter. You can even find over here the powers which this particular CMOS inverter has consumed. So the power which is consumed is 12 microwatt. So this is how you can see the uh, working condition of a CMOS inverter, and these are the different waveforms which you can obtain. This is between the voltage and current. The voltage and current, you can see the VDD which we supplied is 1 volt, and there's a minimum current which is 0.5 milliamperes is a minimum current. And you can also find the waveform between this DC characteristics, input and output voltages. um, and again frequency and time. This is a waveform between the frequency and time. Again, there's an eye diagram which displays all the kinds of all these waves. So this is regarding how it works. I'm going to stop this one. So this is your CMOS inverter layout using this Microwind software. So this is how you're supposed to design any kind of inverter or any kind of analog structures layout using this particular Microwind software. Okay, thank you friends. I hope you have understood this one.